Dear students, in my last video I have discussed how refraction takes place through a rectangular glass slab. And you have seen when a ray of light passing through the glass slab, it is sideways shifted or laterally shifted. That shifting is called lateral shift or lateral displacement. It is the perpendicular distance between the incident ray and the emergent ray. You see now, PQ is the incident ray, RS is the emergent ray. The incident ray when extended, you will see there is a perpendicular distance between the incident ray and the emergent ray. So let us derive an expression for the lateral shift or lateral displacement. So for that you will take the help of little geometry and you will derive the expression. Now I is the angle of incidence, R1 is the angle of refraction. Let me extend this one to this one. So this is the perpendicular definitely. So PQ, R, S, M, let me write here N. So see children, this is I, this is R1, this is I have taken R2 and this is the perpendicular. You see now, if you see this angle and the total angle, they are vertically opposite. So whatever this angle, you apply little geometry, you will get this total angle is I, so this angle will be I minus R1. I minus R1. Simple geometry. Then I want to find the expression for lateral shift. Here in this diagram, Rm is the lateral shift. Let me write it is X. See children, in triangle QRM, in triangle QRM, sin I minus R1 is equal to, apply geometry. So this is Rm divided by QR. Rm divided by QR. So Rm is equal to QR sin I minus R1. Let it be equation 1. Suppose the thickness of the glass slab is T. So Qn equal to T. Now see in this triangle, in triangle QNR, cos R1 is equal to, what is the value of cos R1? You know the trigonometry. So cos R1 is Qn divided by Q1. So Qn is nothing but thickness of the glass slab. I have taken small t. So T divided by QR. So QR is equal to T by cos R1. So now I will put this value in this expression 1. So putting the value of QR in equation 1, so Rm is equal to QR. For QR I am writing T by cos R1 into sin I minus R1. Rm is nothing but the lateral displacement. So this implies X is equal to T by cos R1 into sin I minus R1. So this is one of the expression for lateral shift or lateral displacement. Now X is equal to T by cos R1 sin I minus R1. So let us express the lateral displacement in terms of the refractive index or nature of the material of the glass slab. So we are going to use the Snell's law. Already I have discussed in the previous videos and that will be used here. So X is equal to T by cos R1. Let us open that one. Sin I minus R1. You know the sin A minus B formula. The sin A minus B, sin A cos B minus cos A sin. Just open it. So it will be sin I into cos R1 minus cos I into sin R1. So from Snell's law, we know that mu is equal to sin I by sin R. So sin R Here I have taken R1. So sin R1 equal to sin I divided by mu. So for sin R1 I can write sin I by mu. Again cos R1 is equal to 1 minus sin square R1. Simple trigonometry. So I am putting the values cos R1. So 1 minus sin square I by mu square root. So that is equal to mu square minus sin square I root over divided by mu. So this is the value of cos R1. Let me put the values in that expression. Now let us put the values of sin R1 and cos R1 in this expression. So sin R1, so this is t by cos R1 into sin I into cos R1 minus cos I. For sin R1 I will put sin I by mu. This is sin I divided by mu. So now sin I can be taken common. So t sin I, here what you will get, cos R1 if I will enter inside, you will get here 1 minus here cos R1. So cos I, sin I have taken common, cos I by mu cos R1. Now I will put the value of cos R1 there. So this is, so x is equal to t sin I 1 minus cos I divided by mu the cos R1. So mu cos R1, if I write directly mu cos R1, it will be mu square minus sin square I root over. So this is another expression for the lateral shift or lateral displacement. See children, lateral displacement now depends upon which factors? It depends upon the thickness of the glass slab, angle of incidence, and also nature of the material of the glass slab. Now, what is the maximum value of the lateral shift? How much it can be shifted? So that depends upon angle of incidence. You see now, when I is equal to 90 degree, suppose angle of incidence is 90 degree. So if angle of incidence is 90 degree, what will you get? What is the value of x? X will be equal to, see, sin 90 is 1, cos 90 is 0, so this term will vanish. So what you will get? X is equal to t. That is the maximum value of lateral displacement. So remember children, the lateral displacement or lateral shift cannot exceed the thickness of the glass slab. So this is a very important derivation I have done. So all of you practice and remember, and this will be helpful for your board exam. Thank you all.